Welcome back to All This Math. This is Professor Parker. Make sure you like this video. Make sure you are subscribed to the channel. Make sure you share this video with somebody. All right. Now, what are we about to do? We're about to factor out a GCF from an algebraic expression, specifically a trinomial. Why is it called a trinomial? Because it's got three terms, and the prefix tri means three, just like a tricycle has three wheels. All right. What are your three terms? 3x to the fourth is your first term. Negative 12x to the third is your second term. 21x is your third term. It's got 1, 2, 3 terms. That's a trinomial. We're finding the GCF. What does GCF stand for? Make sure you know that. Greatest common factor. Greatest common factor. All right. So when I show students how to do this, what I tell them to do is this. Separate your coefficients from your variables. Your coefficients from your variables. So our coefficient in our first term is this positive 3. Coefficient in the second term, negative 12. Third term, positive 21. Find the GCF of the coefficients first. Find the GCF of the coefficients first. So I like to write down GCF, put a colon, and then I say, okay, I got a 3, a negative 12, and a 21. I'm going to treat this negative 12 like it's a positive 12, though. And I'm going to just make my GCF of those three just a positive number anyway. All right, so what is the GCF of 3, 12, and 21? This is why in elementary school, hopefully, you learned how to find a GCF of whole numbers. All right, hopefully you learned it. If you didn't, I got videos. That's why you should be subscribed to the channel. I got videos here. I got a factors and multiples playlist where you can learn how to find the GCF and the LCM of numbers. All right. Now, the GCF of 3, 12, and 21 is 3. By the time you get to problems like this, you should already know that. You expected to already know that. All right. Like I said, if you don't, though, go holler at that playlist, the factors and multiples playlist, to learn how to find the factor or the GCF, greatest common factor of numbers like 3, 12, and 21. Now, why is it 3? Because 3 is the greatest or biggest number that can be multiplied into all three of these numbers. What do I mean by that? What's 3 times 1? 3. What's 3 times 4? 12. What's 3 times 7? 21. And 3 is the biggest number that fits that criteria. The only other number that would fit that criteria is the number 1. And 1, we don't really care about, right? We don't really care about it. If 1 is the greatest common factor, that means that the numbers are what we call co-prime or relatively prime. That's what that means. All right. Now, so don't go thinking that 12 is the greatest common factor. No, 4 is not. No. Right. Also, go to that playlist. Like I said, go holler at that playlist, because on that playlist, I show you the difference between factors and multiples. That's what confuses a lot of children. They don't understand fundamentally the difference between a factor and a multiple. So then they get confused. They confuse a GCF with an LCM. That's a problem. All right. We don't want that. So go to that playlist. All right. So for the GCF, though, part of it is going to be 3. The coefficient part is going to be 3. Then I tell students, look at your variables. Look at your variables. You got an x to the fourth, x to the third, and an x to the first power. How do I know it's to the first power? Because I know in the language of algebra or math, whenever there ain't no exponent, that means there's an invisible 1. Invisible 1. Memorize that. When you don't see an exponent, know it's an invisible 1. Even for the coefficients, this is 3 to the first power. This is 12 to the first power. This is 21 to the first power. Whenever there is no exponent written, the exponent is an invisible positive 1. All right. So now, how do you find the GCF of variables? If there's a variable that's in common, all you got to do is say, look, which variable has the smallest exponent? This one got a 4. This one got a 3. This one got a 1. What's the smallest number? 1. So that means that x to the first, or x, is part of your GCF, because that x, why x? Because that's got the smallest exponent. Now, there's a much more robust and comprehensive explanation for that I already provided in another video on my playlist on exponents, right? Exponents and factors and multiples. All right. You can go check that out at your leisure. All right. But this is the GCF right here. 3x. 3x is the greatest common factor of this expression. Now, what do I do with that 3x? What I do is I do an equal sign, and I'm writing an equivalent expression. I'm basically breaking this trinomial down into a monomial multiplied by another trinomial, a simpler trinomial, right? That's the purpose of factoring. We're breaking something down into simpler terms. So now, how do I get what's going to go inside the parentheses, though? What I do is I do division. I divide this first term by the GCF. Then I divide the second term by the GCF. Then I divide the third term by the GCF. I just keep dividing. I just keep dividing. And that's how I find my terms that go inside the parentheses. So what I'm going to end up with is I'm going to first do 3x to the fourth divided by 3x. Now, coefficients. What's 3 divided by 3? 1. What's x to the fourth divided by x? You need to know your exponent properties. You need to learn your exponent properties, especially the division property, which says you subtract the exponents. 4 minus the invisible 1. 4 minus the invisible 1 is 3. So you end up with an x to the third power. Now, when I rewrite this, I don't need 1 as a coefficient. If 1 is your coefficient, you don't need to write it. Understand that it's there, but you don't need to write it. That's part of math language. What's understood don't need to be said. What's understood don't need to be written, right? So when I put it in the parentheses, I'm just putting x to the third. Then I'm going to the second term. My second term is negative 12x cubed. I'm dividing that by the GCF. What's negative 12 divided by 3? Not positive 4, negative 4. Whenever you divide a negative by a positive, you get a negative. So that's going to be negative 4. Then x to the third divided by x. Exponent property, subtract the exponents. What's 3 minus invisible 1? 2. So you get x squared. That's negative 4x squared. Negative 4x squared. Put that in the parentheses. Then we go to the last term. 21x divided by 3x. What's 21 divided by 3? 7. What's x divided by x? Ask yourself this. What happens whenever you divide something by the same exact thing? When you divide 10 divided by 10, you get 1. When you divide 100 by 100, you get 1. When you divide negative 18 divided by negative 18, you get 1, right? So the same should apply with variables. X divided by x is 1. Y divided by y is 1. R divided by r is 1. X divided by x is 1. So that would be 7 times 1. And 7 times 1 is just plain old 7. Take this 7, throw them in the parentheses. It's positive, so we say plus 7. This is our final answer. This is our final answer. 3x times, make sure you know how to say it out loud, 3x times the quantity of, in the parentheses, it's a quantity of x cubed minus 4x squared plus 7. That's the factored form of that. All right, so make sure you know what you're doing. All right, don't be out here looking silly. Make sure you know when it's time to factor and find a GCF, look at your coefficients first. Look at your coefficients first. Then look at your common variables. Then look at them. All right. Then you take each original term divided by the GCF. First term divided by the GCF. Second term divided by the GCF. Third term divided by the GCF. All right. And then you just throw those quotients inside the parentheses. Now, in some problems, you'll still have to keep factoring, right? Not in this example, though. So there are other forms of factoring where you may have to employ or implement in order to find the most simplified, completely factored form of an expression. But that ain't this, and this ain't that. So we're done. Also, you see, I got the brother, the ancestor, Omawale Malcolm X on my shirt. If you're not as familiar with Malcolm X, make sure you study Malcolm X. All right. I would recommend his autobiography, The Autobiography of Malcolm X. I also recommend his speeches. You can listen to his speeches online, or you can buy books that have his speeches transcribed and written within them, read them, analyze them, try to apply what he was saying to current day situation, right, and circumstances for your own betterment, right, and the betterment of our community, right? Practice factoring, study Malcolm X. I'll see y'all on the next video. Peace.